Hello, this is a group assignment for Group 27 BSc 112 assignment. This assignment has been done by Shusinyu, Muti, and Yarabalhaj. These are the steps that we have used in order to fulfill this assignment. In these slides, we're going to be starting with explaining the course learning outcomes, which is the CLO, and then we're going to dive into steps to solve the first equation that we have introduced in our assignment. And then next up, we're going to start to show the steps for the second equation that we are explaining in our assignment. And at the last page, we're going to show the answers for the questions. So course learning outcomes, CLO, is the ability we have acquired at the end of this assessment. CLO 1, for example, explains the concepts of single variable calculus, infinite series, and complex numbers. In CLO 2, we applied the method of single variable calculus, infinite series, and complex numbers. And for CLO 3, we determined a suitable method in single variable calculus to solve various relatable problems. Okay, so the steps to solve the first equation. First, we're given that the volume of the box V is calculated as V equals x times y times z. Since the base of the box is square, we know that x equals y. Also, the volume is provided as V equals 0.5 meter cubed. By substituting x squared times z equals 0.5, we solve for z, giving z equals to 0.5 over x squared. Next, we calculate the surface area, A, of the box, which is given by A equals 2x squared plus 4xz. Substituting z by 0.5 over x squared into the equation, we simplify the surface area formula as A equals to 2x squared plus 4x times 0.5 over x squared. After simplifying, we have A equals to 2x squared plus 2 over x. To find the dimension that minimizes the surface area, we take the derivative of A with respect to x. The derivative of A is equals to 4x minus 2 over x squared. Now to find the critical point, we set A to equal to 0. So now that we know that the derivative of A is equal to 0, 4x minus 2 over x squared is equal to 0. Finally, rewriting and solving the equation, we have 4x cubed minus 2 is equal to 0. We find that x cubed is equals to half. So x equals to y equals to the cubic root of half m. Finally, substituting x squared back into the equation for z, we calculate that z is equal to 0.5 over x squared, which is equal to the cubic root of half m.
For the second problem, we are trying to find the force on the walls of the container when the base of the container is at 5 and 7 meters. Based on our physics knowledge, we know that the force is equal to pressure by area, and pressure is equal to density by gravity by depth under liquid. To solve our second problem, we split our box into 4 of its individual vertical faces. The pressure on one of these vertical faces, px, would be the density times the gravity by the depth under liquid, and the area would be width by d of x, which would be a small change in height. Therefore, to find the force on the entire strip, we integrate the formula for pressure times the formula for area from the bottom to the top of the strip, with the depth as our variable. As you can see, using a density of 1000 kilograms per meter cubed, we found the force on the wall to be 28,447.07 newtons. We then multiply it by 4 to get the answer for all the walls of the container. This gives us 113,788.3 newtons. This is the force on the walls at 5 meters.
Hi, I'm Shu Xinyu. Next, I will explain the second question. Following what my previous teammates said, the principle of this question is the same as that of the first question, so I won't go into details here. It should be noted that the density of the liquid in this question has changed into 1078.5 kg per cubic meter, and the bottom depth has been changed to 7 meters. using the integral formula mentioned in the first question. And these values can be substituted into it. According to the formula, the vertical force on one side is 4401.23. Therefore, the total force reserved is 4 times the force, and the answer is 176,040.9. Finally, let's summarize all the answers to our assignment. The surface area formula for the first question is twice x squared plus 2 over x, and the values of x, y, and z are inquired. The answers to the second question of the two total forces are 113,788.3 and 176,040.9. This is the result of our group. Thank you for your listening.